So as Sherry said, I want to talk about math, and I will dot a bit of technology in as I do so. Okay, did we get on the right thing here? No, I need to put it, I need to see what I'm doing as well. We have a fundamental problem. So I'm going to talk about a different slice to what everybody else is talking about. I'm going to talk about the subject matter of maths. I'm in almost total agreement with almost everything that's been said so far about how we deliver those subjects. I think we are teaching fundamentally the wrong subject in maths. We are insisting the world's population goes through the wrong subject, and I want to explain why that is. So we have a subject in the real world that's all about problem solving, modeling, things that you do where you're trying to use what we call maths to get further in solving problems. And it looks like that. In education, it's all about writing stuff down to calculate things by hand. It looks very, very different. If you're lucky, you use one of these, a calculator, which, by the way, people don't use in the real world very much. So there are two discrepant subjects. And my belief is that that chasm is getting wider and wider, and that unless we fix the chasm, we can't fix the problem. So let me explain a bit more why I say that. You know, the key difference between those is, in the real world, we use computers to do the calculating, almost entirely at this point. In education, we insist everyone learns how to do it by hand, and if they're lucky, they get to use a computer at the end. This is highly destructive, in my view, and I want to explain that. So firstly, why do we learn maths? And in particular, why does everyone learn maths? Well, I think there are three fairly good reasons, as long as it's the right subject. Technical jobs that we all know drive the economy and everything. Everyday living. You cannot live in a modern society, or even a less modern society now, without much more quantitative skills than you had to have even 15, 20, 30 years ago. And thirdly, what you might call logical thinking. You know, a way of thinking about life or problem solving, which is really what maths is about. Maths is a system of problem solving. A way of thinking about problem solving that helps you make more progress in life. So what is math? What do we actually do? Well, I reckon it's about a four-step process. You are posing questions that you want answered. You are then taking those questions from that real world to math, to this language that's incredibly powerful. You're then computing, getting the answer in math, which is step 3, and then you're going back the other way, going from the math to the real world, hopefully verifying and answering your first question, and maybe going around several times in this. Here's the completely crazy thing. We are spending probably 80% of the time in people learning maths learning how to do step 3 by hand. Yet in the real world, we want, computers do step 3 in fantastically well. And what we want is students to spend their time doing steps 1, 2, and 4 much, much better. That's what they actually need. And I also think it'll be much more interesting to them. We'll come on to that. Key point. Maths is not equal to calculating. It is a much bigger subject in my definition of it. And in fact, the only way of defining it as a subject for everyone is to define it in my way. If you want to define it the other way, you're going to end up in a much narrower definition. And I just want to do a very simple demo here. This is something you probably learned to solve at school. You do simultaneous equations. And, that's the key point here is there's an equation. It's a useful tool that you can use. But probably what you don't do at school is make that a cubic, and you get a more complicated answer. But there's no fundamental difference in what we're doing there. You just spend, and in fact, it's even worse than that. The risk of testing the network here. Let me do this. Solve x cubed plus 2 equals 2y, and y minus x equals 5. Right. Well, Siri willing and everything. Ugh. No, it messed it up. Okay. Solve x cubed plus 2x equals 2y. Well, I'll have to leave that demo for later. Anyway, that's always the trouble with these. But I mean, the key, actually, what I'll show you is what it would have produced, which is pretty, well, let me do that later if I have time. It's, the key point is, usually, I can actually talk to my phone, and I can get that answer right out. You've got to ask why. If and when it works, if I can talk to my phone and get an answer out, why we're spending 10 years of everyone's life teaching them to fail to be able to do that. Most people couldn't do this. Okay. Now, one key point is I'm talking about maths for everyone. There's a great subject called ancient Greek. In fact, I even studied it at some point. I'm not in any way saying people shouldn't pursue interests that they have themselves. They're interested in ancient Greek, that's fantastic, and we should help them to be interested in those things. They can pursue that. The question is, do you want to teach ancient Greek to people at 21,000 lifetimes a year, which is what it's costing the world right now to learn hand calculating? You can't justify it. And that's the sort of key difference between math for everyone and this sort of history of hand calculating that we're currently delivering. So just to be clear against what everyone else has been saying, I'm talking about a subject that's computer-based. As in, the subject in the real world changed because computers automated it. We now have to change subject in education to match that. There is also what I call computer-assisted, which is let's improve the process of learning, which is what many people have been talking about. Obviously, that's very important, and we need to multiply these two together. But I think maths is fundamentally different because the subject changed so dramatically in a way that, for example, history hasn't. I mean, history has evolved in several senses, actually, but history has evolved over the years. But I don't think the subject fundamentally changed because computers automated it. The other thing I want to say is more practical is more conceptual. Right? This nonsense about the idea that if we want to do stuff with computers, it will get dumbed down. Yes, doing it the wrong way with computers, you can dumb it down. But the real world out there, the question is, did math get more conceptual when computers got injected? And the answer is far more conceptual. If you do the same in education, the same will apply. There is no gap here between sort of the vocational, in a sense, and the conceptual. And we should be teaching calculus to 5-year-olds and figuring out what happens when you have an infinite number of sides. We should be doing primary school thermodynamics and actually modeling things in real time. This is a bit of a tech demo as well. This is a thing called a computable document that we have that allows you to mix documents and real computation in one, which is why that's working. It's actually calculating in real time here. If you remove the computer, you remove the context. This I only realized quite recently. The reason maths is such a big deal to governments, to everyone else, why essentially every government in the world is panicking about how people are not doing enough maths. The reason for that is because maths is now applicable to virtually all areas of life. This was not true 100 years ago. It was applicable to a very narrow area of life. Accounting, physics. Biology was a disaster for the most part with maths at that point. Couldn't do the calculating. The big barrier was calculating. And so what we've done is, if we remove the computer, we are removing the very instrument that allowed maths to be applied to all of life. The thing that makes it important. So if you remove that from education, you will remove most of the context. And that's when we get these dumbed down questions. You can't set a very meaningful data analysis question without a computer, because you're analyzing 5 data points by hand. Nobody does that. The hair that comes up with that doesn't occur. I also want to talk about, particularly following Evan's talk about coding, and how does that relate? One thing I sometimes say, it's not a perfect analogy, but composing is to English what coding is to maths. I actually think coding is a more important subject even than has been recognised recently. It's great to see the UK moving forward on reintroducing coding, of course all the Raspberry Pi things, everything like that. But my point is actually that coding is the way you would describe STEM or maths. It's just the way you talk about it. You can't really communicate these things without writing code to describe it in any meaningful way in the modern world. So it's as central as that. And I thought, just to live dangerously, I would actually try and just do a little bit of coding here live. And so what I wanted to do is, this is a typical thing people need to do in real time. What do I want to do to this image? Well, I'd like to edge detect me, that's me. And I thought I would just try and make a little app, if I can, very, very quickly. And it's quite nice that one can do this quickly. It's always a little harder when you're actually doing it in front of people, and because you make mistakes. And let's see, what I want to do is change the possible effects. So let's do edge detect, and let's say blur is a possible thing. And I think I might also put in a parameter. So let's say we can have n going from 1 to 5. But now, since I program in a rather non-linear way, I need to go back and say that's the effect, spelled right. And I need to maybe go and slot in the effect. It needs to go probably to n. No, I've done something goofy there, maybe. Let's see whether... No, I've done something crazy, which somebody can probably see that I can't see. Gosh, I can't have another demo that doesn't work. That would be bad. No, it worked. Okay, so what I was trying to, I left the bracket out there. So what I'm doing here is I made a little app which allows me to change the level of detection or to turning to blur or not blur. I'm doing some image processing in real time, and I guess I built that in, I don't know, under 60 seconds or something like that. So that's a hope. Maybe it's the first thing that's been built in this building in that way. I don't know. So the key point I want to say is, when in education, what's happened in education, and a lot of people said this in different ways, we've got tremendous automation in different areas that's happened. And what I'm particularly talking about is in maths, we automated the subject better than anyone could ever imagine. The key thing that caused the subject not to work, in many cases, for literally thousands of years, we fixed better than you could ever have imagined with a computer. And you've got to decide in education, what do you do when something gets automated? Action one, you make everyone do the same thing by hand that the machine is now doing and learn how to do that. I think that's totally the wrong approach. The other approach is you stand on the automation that you built and you said, now we've got that. They don't have to learn all that. They should learn the better stuff they can do with the automation that we've got. That's what's happened to STEM. That's what needs to happen to STEM. And we found in computer-based math to fundamentally change the curriculum to make this happen. And it will happen. I mean, let's understand, there is no justification. In the long term, there is no way that maths can diverge from the real subject and be justified across the world. And so we started with Estonia. There were some various, we do problem-based type things. We started to build a curriculum probability and statistics, starting with am I normal and questions like that that I think are good for teenagers. We use the math to get them to solve the problem, and then the computer is the tool for the maths. The maths is the tool for the problem solving, the computer is the tool for the maths. So Estonia's first. The question is, where's the UK in this? The sad thing is, the UK and the US actually, I think we have very good problem solvers here, fundamentally. Indigenously, I for some reason believe Brits are quite good, and Americans are pretty good problem solvers. So I actually think this approach to maths would take us much further up whatever league tables you want than our competitors that Lord Putnam talked about earlier. Instead, we're playing on the wrong playing field. We're talking about how do we compare ourselves with countries who do really well on procedural maths, which isn't really what you need anyway. So actually, we could do really well, but we've actually got to jump and go down this path. We mustn't mix up the mechanics of the maths, the mechanics of the moment, as I call it, with the essence of the subject. And hopefully you can help us unscramble this from some interesting statement. Just to finish, I'm rather pleased that in 2 weeks in New York we have a computer-based maths summit hosted by UNICEF. The fact that UNICEF have understood that maths is important to improving children's lives around the world, I think is highly significant, and I'm obviously very pleased that we've managed to collaborate on that. Thanks very much.